Okay, guys, it's Tuesday, March 31st. This is Advanced Math Honors, Mods 2, 3, and 4. If you'll remember, yesterday we covered a topic called the Law of Sines. Today, we're going to move on and cover a topic called the Law of Cosines. So just as I suggested yesterday, if you had a piece of paper out on your table, on your desk, wherever you're at, phones away, everything else off to the side, focus and pay attention. Again, this should be about a 15-minute little video clearly explaining a topic called the law of cosines. So 331 is the date in the top left corner. Law of cosines is the title of your notes. Start out for problem number 1 by drawing the triangle that you see on this paper. Again, it is not a right triangle. We've got triangle ABC. Angle A at the top is 28 degrees. So side A across from angle A is down at the bottom. And then we've got angle B and angle C. So across from those angles are, of course, side B and side C, whose sides are 8 and 10. So have this as your picture ready to go. And our job is to find all the missing pieces of that picture. Now, it's not a right triangle, so just like yesterday, SOHCAHTOA is not an option. Law of sines is not an option either if you look at this picture and think about it. Let's say you wanted to try the law of sines, you would end up putting what? A over the sine of 28 degrees and set that equal to pick one of the other two sides. Let's say we picked 10 over, and then we looked across from that side and we didn't know angle B. We would have the sine of angle B. So if you did try any combination of the law of sines that we learned yesterday, you would try to cross multiply and solve a proportion that has two unknowns. That, of course, would not work. So we're going to attempt to use a second law that was created called the law of cosines. Now I'm going to write the law down. And again, it's going to look a little scary with all the letters and formulas involved, but we'll slow things down, try it on this problem, and then a couple of other unknown missings on certain problems, and I think you'll be okay. Okay, right now, the law of cosines, write this law down, says the following. A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Oh boy, that looks crazy. Again, A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Even though that looks a little confusing, if we used words instead of letters, in essence, that formula means you can take any side that you want and square it and set it equal to the second side squared plus the third side squared minus 2 times the two sides that you just picked, B and C on that same side, times the cosine of the angle that's opposite or across from the side that you started with at the beginning. So notice the little a at the beginning matches up with the capital A at the end. That's important to note. So if I tried to apply this law on this problem, okay, obviously we're looking for side A. All I want to know right now on this picture is how big is side A. So I'm going to write A squared equals, okay. Now I'm going to take B and C as the other two sides that, of course, I haven't picked yet. So if A squared is on the left, on the right, we're going to take 10 squared plus 8 squared minus, I'm following the formula here, 2 times B times C. So that's 2 times 10 times 8 times the cosine, and then it's angle A. Notice capital angle A is across from the side that we started with, which was little a over here. So in this case, angle A across from side A is 28 degrees. So everything you need is filled into this formula. So cleaning that up just a hair, 10 squared would be what, 100, plus 8 squared is 64, minus, now we've got 2 times 10 times 8, so that's 20 times 8, which is 160 cosine of 28 degrees. So a squared equals, notice you're going to add 100 plus 64 and get 164 minus, and then that 160 times the cosine of 28 degrees. Now don't take 164 and subtract 160 and get 4. This 160 is dot connected to the cosine of 28. So you literally take your calculator and type that entire expression in right now. So I'm going to do that on my calculator. You do it on yours. You got 164 minus 160 cosine of 28. Enter. And on my screen, we'll go 3 places here, 22.728. And of course, to finish solving for side A, we're going to square root both sides. So if I square root that value, I'm going to square root that answer that was on my screen, 22.728, and we're going to get to the nearest tenth since it's a missing side. I've got 4.767, so that'd be about 4.8. And we've got our missing side A at 4.8. Now, that now is how big my only missing side was. If I asked you to find angle B or angle C and find a missing angle instead now, instead of the missing side, we would be able to do that by setting up a similar situation here. But think about it. Let's say I want to find angle B. If I'm looking for angle B, doesn't this formula, this law of cosines, need to start with little side b? So I literally would write b squared equals a squared plus c squared minus 2 times a times c times the cosine of angle B. Oh, so since I'm looking for angle B, I want the cosine of angle B to be involved in my formula. So if capital B is at the end, little b had to be at the beginning. That's my logic for picking that formula to utilize now to find angle B. So plugging in all the known values, we'll go quicker here. B squared would of course be 10 squared, which is what? 100. Equals a squared. Well, a, remember, was 4.8, and when you square it, you're going to get that 22.728 value. So a squared is going to be 22.728 plus c squared, which is going to be what? 64, minus 2 times a, which is 4.8, times c, which is 8, times the cosine of angle B, which is my unknown. All right, cleaning this up a little bit, we've got 100 equals, if you add 22.728 plus 64, we get what, 86.728 minus, okay, I'm going to pull out my calculator. I'm pushing 2 times 4.8 times 8, and I'm getting 76.8 cosine B. And just like that last problem when we discussed this, you don't subtract those two numbers. That 76.8 is dot connected to the cosine of B. So we're actually going to subtract over the 86.728 and subtract them to the other side. So 100 minus 86.728 leaves me with 13.272 equals negative 76.8 cosine B. Now to get this cosine of B all by itself, I would divide by negative 76.8. Those would cancel, and I'd have cosine B equals and then I would divide that all out on my calculator. So I've got that 13.272. I'm dividing it by negative 76.8. I'm hitting enter. I'm getting negative 0.172. I'm leaving that on my screen. And now to find a missing angle, remember it's always the inverse cosine button in this case. So I'm hitting second cosine, and then that last answer that was up on my screen, and I end up with an angle for angle B of, it looks to me like 99.95. Since we've been rounding to the nearest tenth, that would be 100 degrees. Wow. And I now know that 100 degrees would be the missing angle B. Of course, to get angle C, we could now just do what? Add 100 plus 28 is 128, giving me 52 degrees for the third angle. And we found all our missing parts using a law called the law of sines. Okay? A couple more things to point out on that. Let's say, we'll call this problem number 2 in your notes, and I'm just going to ask one quick question. Even if this is an obtuse triangle to begin with, let's call this V, this Q, and this W. And let's say this side here is 6, this side is 8. This obtuse angle, let's say, is 108 degrees. And all I want to know on this ACT question is, hey, how big is side V over there? Well, once again, that's not an hypotenuse, so we can't use SOHCAHTOA. For the same reason as the last problem, law of sines is not an option, so we're going to use the law of cosines to find side V. Obviously, if we're looking side V, my formula is going to start V squared equals, and then following the pattern of that formula for the law of cosines, wouldn't we end up doing Q squared plus W squared minus 2QW times the cosine? And since we started with a little v, we're going to end with a capital V. All right. With that formula now in place, I would go V squared equals, Q squared is going to be 8 squared, which is 64. Look at your picture for W squared. That would be, since W is 6, we would have 6 squared, which is 36, minus 2 times Q times W. So that's 2 times 8 times 6 times the cosine of capital V. Again, that's my unknown. Cleaning this formula up, 64 plus 36 would be 100, minus 2 times 8 is what? 16 times 6 would be 96 times the cosine of V. Again, I will point out, don't you dare subtract 100 minus 96 and get 4. That's dot connected to the cosine of V. Those are not like terms. You're literally, since angle V is 108 degrees, you can put 108 in for the V. So this V becomes 108 degrees. Oh, so everything I need is right here. Look, it's 100 minus 96 cosine 108. So pull out your calculator. Let's do the work there. If I type in 100 minus 96 cosine 108 and hit enter, my calculator is saying 129.6656. So I'll go to 129.666 on my paper. But of course, I square root both sides. And if I square root that answer, 129.666, that's on my screen, I end up with, it looks to me like 11.38. So 11.4 is my missing side V. And that's, again, an easy way to find a missing side on a non-right triangle using this time something called the law of sines, or excuse me, the law of cosines. Finally, my last question for the notes, question 3. What if you've got a triangle? We'll draw the picture and we will call this triangle DEF. F. So let's say side D on this side is 7. Side F over here is 4. And side E at the bottom is 6. Notice, oh my goodness, I gave you all 3 sides of this picture. Couldn't I now ask the question, find all 3 of those missing angles? Well, let's just practice finding an angle one more time here. Let's say we wanted to find angle D. If I'm looking for angle D, my formula's got to start with little lowercase d, agreed? So I'm using d squared equals e squared plus f squared minus 2ef times the cosine of capital D. And since I know all 3 of my sides, those are going to get plugged into this formula, correct? So d squared would be 7 squared, which would be 49, equals e squared would be 6 squared, which is 36. F squared would be what? 4 squared, which is 16, minus 2 times 6 times 4, right? Because that's my 2 times my E times my F, times the cosine of capital D, which is the unknown angle I'm seeking. Cleaning this up a little bit, we've now got 49 equals 36 plus 16 would be what? 52. Minus 2 times 6 is 12 times 4 is 48 cosine D. Shove the 52 to the left side. 49 minus 52 would be negative 3 equals negative 48 cosine capital D. To finish getting cosine D by itself, I can divide by negative 48. Those would cancel. Obviously, now when I type this into my calculator, I'm hitting what? Inverse cosine, because I'm looking for a missing angle. Agreed? So on your calculator, you're hitting second cosine. Now, when you type that fraction in, you can ignore the negative signs, because we all know a negative over a negative gives us a positive, correct? So I'm literally, again, I hit second cosine, and I'm typing 3 divided by 48. And I'm getting 86.4. So angle D would be 86.4 degrees. And I found angle D, and I would plug it back in here now. And of course, to get angle, let's say E or angle F next, we could now do the same thing using the law of cosines. Find angle E or angle F, whichever one you picked. And once that's found, you add them together, subtract from 180 to get the remaining angle. So the point of that problem is, even if you're given a triangle where all 3 sides are known and none of the angles are known, you can find all the missing angles based on the values of those sides, again, using a thing called the law of cosines. I hope that makes sense. Remember, if you ever are confused at the end of a session, you can always go back and watch the lesson again. If you've got questions, obviously you don't have the ability to stop and ask me that question, but you do have the ability to go back, replay the video, hit pause or fast forward and get to where you need to reiterate some of the points that I just made. Okay? So with that lesson in mind, your job now is to attack a homework assignment. That homework assignment I'm going to put down in front of you right now has 3 questions on it. All right? Problem 1, problem 2, and problem 3. Your job to do this homework is to put them on a separate sheet of paper, show your steps, show your work, circle your final answers, and then scan and email to me those results, or take a picture of and email to me the results of these 3 homework problems. Yes, you'll get, like I said yesterday, a couple of points for trying each problem, a point or 2 for the process involved, and then a point or 2 for your final answer. So we are grading for correctness. Your evaluation for this topic is simply taking this little 3-question homework quiz, emailing me your results. I will grade it, I will record your results. And by the end of this week, you're going to have one grade, one weekly grade, comprised of the points you accumulated on all the homework you've been doing. So since now it's March 31st on Tuesday, this assignment would be due on Wednesday, April 1st by noon, if you could, so I can keep up on a daily basis with you progressing through these lessons. So here's a picture of the homework. Copy that down, turn it into tomorrow at noon, okay? Thanks, guys.